This video is about graphing a system of linear inequalities on the coordinate plane and identifying the solution set of a linear inequality. So, solving systems of linear inequalities, we're going to graph both of the inequalities on the grid, and wherever their shaded regions overlap is the solution to the system. So instead of having just a point that intersects like we had when we had linear equations and we're graphing, now it's going to be an overlapping shading area. So in number one, we have y is greater than 3x minus 9, and y is less than or equal to 3x, 3/4 x plus 1. So in the first line, we know that our slope is going to be 3 over 1 because 3 is in front of the x, and our b value is going to be 0, negative 9. So I'm going to go to negative 9 on the y-axis, and I'm going to go up 3 over 1 all the way across my graph. Then I need to look at the inequality. Because it's a greater than sign, that means it's going to be a dashed line, and I'm going to shade above. So I'm going to draw a dashed line. Now with shading, instead of just scribbling the shaded area, because there's going to be two different shadings, I'm going to use highlighters to show the section that would be highlighted. It's okay if I leave some gaps because I don't want the colors to overlap that I can't notice what's what. So I'm going to use horizontal stripes for my first graph, and then I'm going to use vertical stripes of a different color for my second graph. So the second equation is y is less than or equal to 3/4 x plus 1. So our slope here is going to be 3/4, and our b value is going to be 0, 1. So I'm going to go to 0, 1 on the y-axis, and then I'm going to use the slope up 3 over 4 across my graph. Because I want to make sure I have a straight line and I have an accurate area of the overlapping shading, I'm going to continue my graph in the other direction by using the opposite slope as well. So I'm going to go down 3 over 4, down 3 over 4. Now, looking at the sign, it's a less than or equal to, so that means it's going to be a solid line, and that we are going to shade below. So I'm going to connect those green points. And then I'm going to shade below my graph. So this time I'm going to use vertical stripes. And I can start to see where those colors are blending together to see my overlapping shaded region. So now that I have my overlapping shaded region, I need to figure out if the point's a solution or not. So the first point that they give us is negative 3, 5. So negative 3, 5 is only in the one color shade area. So this is a solution? No, because it's not in the shaded region with both colors. What about the point 1, negative 2? Well, 1, negative 2 is in the area with both colors. So yes, this is a solution. And then the last point, 0, negative 9. Well, 0, negative 9 is on a dotted line. Remember that we can't have solutions if they're on a dotted line, so this is also a no. So let's try another graph. So in number 2, the first equation, we have 4y plus 8 is less than negative x. So I'm going to need to solve for y first. So I'm going to rewrite the equation. And the first thing I'm going to do is I'm going to subtract 8 from both sides. And I get 4y is less than negative x minus 8. I'm going to divide everything by 4. So I get y is less than negative 1/4 x minus 2. So in this case, I know that my slope is negative 1/4 and my b value is 0, negative 2. So to graph this, we're going to go to negative 2 on the y-axis. I'm going to use my slope down 1 over 4, down 1 over 4. So that again, accurate line. I also want to go the other direction. So I'm going to go up 1 over 4, up 1 over 4. Then I look at my sign. Because it's a less than sign, we are going to have a dashed line, and we are going to shade below. So I'm going to dash this line first. And then I'm going to shade below my graph. If you want to color the whole section and you can, I just use lines so it's a little bit easier to see what's overlapping and what's not. Then our next equation that we have is negative 3y is greater than x minus 9. So in order to get y by itself, we are going to divide everything by negative 3. Remember, when we divide by a negative number, we have to flip our inequality sign. So we now have x is less, or y is less than negative 1/3 x plus 3. So for this graph, we're going to go to 3. We're going to go down 1 over 3, down 1 over 3, down 1 over 3. I'm going to use the opposite slope as well. I'm also going to go up 1 over 3 in the other direction. And then looking at my inequality sign, because it's a less than, it's going to be dashed. And again, we're going to shade below. So I'm going to have another dashed line. And then I'm going to shade below my graph. And we can start to see as we get a little bit lower where our overlapping region is. So is negative 3, negative 7 a solution? So we're going to go to negative 3, negative 7, place a dot. That's in the overlapping shaded region. So yes, this is a solution. The next point to test is 0, negative 2. Well, 0, negative 2 is on a dotted line, so this is not a solution. And then our last point is 3, 1. Well, 3, 1 is only in the green shaded region. It's not in both, so this again is not a solution. Remember, it has to be a solution if it's in both shaded regions of both colors. Number 3, we have x plus y is greater than 5. So in order to graph, we first need to solve for y. We're going to subtract x from both sides. Y is greater than negative x plus 5. So on the y-axis, we're going to go to 5. And we're going to use the slope of negative 1 over 1. So I'm going to do that all the way across the graph. I'm also going to go the other direction and go up 1 over 1 in the other direction. Then looking at my inequality sign, it's a greater than sign, so it's going to be dashed. And we are going to shade above. So we have our dashed line, and then we shade above for this graph. And then our second equation is 2x minus 3y is less than or equal to 24. So again, we need to solve for y. So the first step would be to subtract 2x from both sides. So we get negative 3y is less than or equal to negative 2x plus 24. Then we're going to divide by negative 3. Everything is divided by a negative, so we're going to flip our sign again. So y is greater than or equal to 2/3 x minus 8. So in this case, our slope is 2/3, and our b value is 0, negative 8. So I'm going to go to negative 8 on the y-axis. I'm going to use the slope up 2 over 3. And then I'm also going to go the opposite direction, down 2 over 3, so I can get a good line. This time it's a greater than or equal to sign, so that means we are going to have a solid line, and we are going to shade above. So we have our solid line, and then we are going to shade above. And as we shade more of the graph, we start to see our overlapping region. Let's look at one more graph with vertical and horizontal lines and graphing our system of inequalities. So the first equation is y is greater than or equal to 5. So remember that y's are always horizontal lines. We're going to go to 5 on the y-axis. Based on our symbol, it's going to be a solid line. And because it's greater than, we are going to shade above. So we have a solid line going through 5, and we are going to shade above our line. Then our second equation is x is less than 2. So if x is less than 2, remember x is our vertical line, so we're going to go to 2 on the x-axis. It's going to be a dashed line. And because it's a vertical line, this is a little bit tricky for shading because there's not an above and below. So think about it like it's a coordinate plane. And we are going to shade to the left because it's pointing left. So our shaded region where they overlap is up in that top left corner. So our solution set would be up in that top left corner. Lastly, determine whether the ordered pair is a solution to a system of inequalities. So remember, just like a solution to a system of linear equations, the ordered pair has to make sense in both equations. So in number 5, we're going to substitute 8 in for x's and -2 in for the y's. So when I rewrite the first equation, I have 2 times 8 minus -2 is greater than 4. So we have 10 plus 2 is greater than 4. 12 is greater than 4. So that makes sense. So because it works in the first inequality, we also have to check it in the second inequality. So we have 8 plus 2 times -2 is less than or equal to 10. So in this case, we get 8 minus 4, which is 4, and 4 is less than 10. So yes, this is a solution to the system of inequalities. When we tried in number 6, we're going to put 1 in for x, and we are going to put 4 in for y. So in the first equation, we have 3 times 1 plus 5 times 4 is greater than 4. So 3 times 1 is 3, plus 20 is greater than 4. 23 is greater than 4, so this one works. In the second inequality, it's x is greater than -2. So all we're going to substitute in our x value, which is positive 1. So is 1 greater than 2? No. So that means that this is not a solution.